Marcel Groten is the managing director of DoMicro, and he's joining us probably from Eindhoven. I love that city. It's one of the deep tech hubs of Europe, and he'll be telling us about insights in electronic design and integration for flexible hybrid electronics applications. So, hi, Marcel.
Right.
Nice to see you.
Hi, Kasia. Good to see you again.
Very
Yeah.
nice to see you. Yeah,
Yep.
welcome on the stage. And yeah, when you're ready, share your slides and you can jump right into it.
Yeah, sure. Yeah, but just a small note on Eindhoven, because I remember your great show in 2022, and I'm really hoping that TechBlick events will turn back to Eindhoven. It was a great event in those days. So let's see.
Thanks for. Well, I mean, the venue was too small for us, so we moved to Berlin. This year we were here in Berlin.
Right.
We do have an event in Eindhoven, though. For those who are interested in the previous presentation, it's on micro LEDs. So we have a micro LED presentation, conference and exhibition in Eindhoven in September, and we are looking maybe, maybe 2020.
We will see.
Or so.
We'll stay in touch.
We will see. Yeah. Indeed.
Okay. Well, as discussed, I was just pitching. Let's say this time. Since we are around in industry already for a while on technology development and inkjet printing, I would love to highlight, let's say, the integration of print electronics, because usually when you perform any inkjet printing or print electronics circuitry, actually you still need to put some strength in creating a real functional device or functional prototyping activity. And this is why I was actually pitching this presentation and trying to shed some light on our efforts to create the application. And those applications, as we are positioned as being a service provider or a project company, so to speak, providing printing technology and also prototyping. We're prototyping for customers, several customers in different areas, semicon or electronics, automotive, where we can provide the integrated applications, where flexible electronics is actually a part of that. Because conventional electronics is abundant and worldwide available, and all those components and all those processes and industries are familiar. They have standardized processes, low cost, high volume. But typically in flexible hybrid electronics, it is creating new applications, and due to the form factor and additive technology, it creates new possibilities. So what we see and what we are asked for is actually combining them. So what we found is and meet our customers in their needs, not only in flexible hybrid electronics, but actually also in developing the electronic applications. So combining that is the name of our game, and as we presented, over the years, our capabilities in inkjet printing, which is this digital, patterning activity. We use the Zeus Microtech LP50 systems. We explore the materials and create the assemblies also with die bond, pick and place technologies. And for that, we have our laboratory, our clean room, where we have several of those equipments. We can bond, we can do micro positioning, we can do screen printing. So we have a kind of nice technology kitchen where we can provide and integrate. But as you can see also on the bottom right, we also have this system integration of electronics capability, where we put, let's say, this circuitry and the electronics functionality into play and into work. In the first part of our company years, we focused on the technology of cells and how to integrate also the flat bare dies, and using inkjet printing as a neat interconnection technology, due to the fact that you can go down to, let's say, 50-50 track gap, and having the ability to do the optical alignment and no touching surfaces. This is the, let's say, approach we took to integrate even bare dies. Face up would be one of those advantages, but we also can do the flip chip and die bonding activity, as you can see here, and by doing so, creating some demonstrators like Bluetooth or microcontroller integration into PTPN foils, and then creating, let's say, even touch pads or proximity sensors, NFC functionality, creating this functionality. But to go beyond that, typically you need to develop also the hardware and the software to create a full-fledged functional electronic device or electronic module or system. And for doing so, it's we do use the V module as a controlled development process, where the competence on electronic design is available. We use electronic development tools like Altium or MatCAD to model and to design the schematics and the PCB layout. And we have within our laboratory also our electronics test lab, like oscilloscopes and heat cameras, really to analyze the design and to create a system. And this structural approach then moves us through these stages of electronic design, like the layout, like the schematics, and also do the simulation and measurement and qualification for such an application design. And this is what brings us actually into system qualification. So having flexible hybrid electronics circuitry combined with electronic components, creating wireless solutions, power, sensing, data communication, and human interfaces, but also the firmware which you need to drive the microcontroller, and even app development for wireless control of the total system is one of those areas. And here is, let's say, then one of our let's say, examples of creating a combination of flexible hybrid electronics, wireless powered switching device for smart glass applications, where we can drive PLDLC film in a wireless mode, making a very flexible and flat integration of electronics, including printing electronics solutions. And one of those other topics typically has been just a gadget for marketing purposes. It's kind of a beam me up Scotty button, which kind of holds some LEDs based on touch, capacitive touch functionality, where the printing and integration of such prototype was created. So this is actually what we're up to, what we're doing. So not only the technology part, but also the electronic design and electronic integration, which really creates the prototype for customers to show what we can do. And in such a way, we provide consultancy and contract development, development of prototyping and integrating printing electronics and also conventional electronics into the project. Usually we go through phases where we just demonstrate feasibility up till, at the end of the phase, go into preparing productivity at the end of the day. If we go for small series like 1, 10 or 100 or even 1,000 pieces, which we're capable in doing within our laboratory. And this is how we continue and provide value for our customers, prototype development, integration, and support companies in their electronic product development for new applications.
Yeah, very nice. So the floor is open to questions. If the audience have questions, please do type in. One general question from me is, you have a lot of experience in this industry, and from a very particular kind of standpoint, what would you say are maybe the top 2, 3 biggest challenges in flexible hybrid electronics in FHE?
Right. I would say, to really get a high volume, reliable integration, as far as I can see. I mean, what we do is typically prototyping. And I only have seen, let's say, IEE in Luxembourg, driving print electronics for high volume for automotive industry. I was really impressed with there, but I haven't seen so much, companies, really in this phase. And the majority of exploring this technology is still in kind of, 306 or 7 mode where actually it is about product development, okay, and qualification. I mean, even printing, if you go for electronic design, you need this simulation modules, for instance, and all the performances. Like print electronics and solid copper lines of 80 micron on PCB is totally different if you talk about wireless functionality. So there is quite some effort still to go to really qualify a print electronics system, so to speak.
Okay, very nice.
Okay.
So one question from Sean is, can you speak to your materials and approaches for electrode interfacing conventional PCBs with your flexible electronics? Do you experience any adhesion issues with the flex circuits? And and does adhesion determine which printing technique you use?
Absolutely. We're on top of that. So it's about let's say several ways of bonding the PT or PN or printed silver on copper and vice versa. We use, for instance, anisotropic conductive film, so thermal compression bonding or conductive glue. These are areas, but also our friends from Norway, from Condaline, have a great solution and technology for that, with their tape. So yes, this is one of those areas where we work on. And conductive tape is a very straightforward approach to do that.
But the following question for that is, I mean, does the adhesion determine which printing technique you use?
Sometimes it does, because we experience, for instance, issues with the screen printed silver, which tends to be soft. Mm-hmm. And then you end up with quite a hassle to bond or glue, or because this material is just not really stable. It's kind of conductive, but it's not stable if you do a mechanical compression. So it's really a case to case. It's application development and dependent on process loads or whatsoever. I mean, we did a project for a optical sensor with 300 bonds with a pitch of 100 micron. Okay, and then try to interconnect them without applying heat, without applying force. So we did quite some research on potential interconnection methods.
Very nice. Another question is, do you experience overheating of the circuits, which would cause you to limit the current you pass through the circuits?
Say that again, please.
Do you experience overheating of the circuits, which would cause you to limit the current you pass through the circuit?
Yeah, sure. I mean, typically this is now typically an area where print electronics has a weak spot, so to speak, because the conductivity for printed nano silver or nano particles or sintered, is typically much lower, and also the thickness is much lower than standard PCB or FPC applications. So yes, there is a limitation, but as said, it's a kind of how do you deal with that in a typical application, because by printed electronics or flexible hybrid electronics, you usually have the ability to spread out your functionality over larger areas, rather than you try to minimize your surface area in a very small spot where you can get heat spots and burn-in issues or burning issues into your PT. But yeah, we have seen that. It happens. But that's prototyping, huh? You try to engineer that around.
Very nice. So thanks a lot, Marcel. And Marcel's going to be around at the break. We just have one more talk to go to the break. So if you have further questions from him, just hang around and meet him at his booth or kiosk. So yeah, thanks a lot again for the nice presentation.
Thank you.